Hey guys, Mrs. Flanagan here. Today we are going to talk about two-way tables and conditional probability. This is what a two-way table looks like, and we are going to use this table to answer the following questions. How many girls can bike to school? So we need to look at girls. Girls is this row here, but we're only interested in the girls who can bike. That is 9. And what percentage of students are girls who can bike to school? So because we want to know the percent of students, there's 30 students total, so it's out of 30. And the girls who can bike are 9, which if you type that into your calculator, it will give you the decimal 0.3. And because we want the percent, we need to multiply by 100, and that gives us 30%. And what's the probability that they are a girl and can't bike? A girl and can't bike is 10, and 10 out of 30, or written as a decimal, is 0.333, or written as a percent, it's 33.3%. Remember, we multiply by 100. We multiply the decimal by 100 to get the percent. And what is the probability that they are a boy and can bike? So boys are up here and can bike is 7. And 7 out of 30 written as a decimal is 0.23. Multiply that by 100 to get the percent, which is about 23. Let's put another decimal here so that we can have 23.3%. And the probability that a student can't bike to school. So now we are looking at can't bike. There's 14 that cannot bike to school. So 14 out of 30. And writing that as a decimal is 0.467, or as a percent, it is 46.7%. And the probability that they can bike or are a girl, the word or means we're going to add together those who can bike and those who are a girl, but we're not going to duplicate anything. So those who can bike, 7 boys and 9 girls. So we need to take the 7 boys and add it to the 9 girls that can bike. And now we need to add that to the girls, which are 9 and 10, but we've already counted this 9, so we need to add the 10. And 7 plus 9 plus 10 is 26, so it's 26 out of 30. And writing that as a decimal, 26 out of 30 is 0.867, and writing that as a percent, it's 86.7%. With conditional probability now, we are no longer going to use our total as the denominator. Instead, we are narrowing down our focus, and our denominator is going to change. So this notation right here is the probability of B given A. And A, whatever comes after the word given, is our new denominator. And this example then, if we know that a randomly selected student bikes to school, so that's our given part, we're given that the student can bike to school, so this right here is where you're only looking at just these numbers. We're only looking at the 7 and we're only looking at the 9. We're not looking at any other numbers. What is the probability that the student is male? So of these numbers, which one is the male number? Well, that's the 7. So we have 7, and then the new denominator is the total of those kids that bike to school. So there are 16 total kids that bike to school. And 7/16 as a decimal is 0.438, and as a percent is 43.8%. Now, if we know that a randomly selected student is male, so this is our given that we're only looking at the male students, so the boys, what is the probability that the student bikes to school? So now we are only looking at the boys. And we want to know of the boys, which one can bike to school? That's 7 of them. So 7 of them bike to school. And the denominator is the male total, so the boys total, that's 11. So 7/11 is 0.636, which as a decimal is 63.6%. And with this notation, the biggest thing to take away then is whatever comes after our given, that is our denominator. So here, given A, the number in A is our denominator. Given B, the number in B is our denominator. All right, this is actual data from the Titanic. So we're going to use this data to find some probabilities. How many males were there? So here are the males, and we want the total, which is 1,690 males. How many females were there? So this is females, and there were 425 females. And how many total people survived? This is our survived information, and there were 654 people that survived. So now when we figure out the probabilities, it's important to recognize if our denominator is going to be the total, like we've been doing with our simple probabilities, or if the denominator is going to change because of what we've been given. With this first one then, notice that nothing has been given, so the denominator is going to be the total. So our denominator is 2,115. And we want to know the probability of male. Well, there are 1,690 males. And so writing that as a decimal, it is 0.799. And writing that as a percent, we get 79.9%, but we need to round to the nearest whole percent, so this rounds to 80%. And for this one, we want the probability of S. S is survived. Notice nothing's given, so the denominator is going to be the total. And how many survived? 654. And writing that as a decimal, we have 0.309. Writing it as a percent, that is 30.9%. But we want, again, to round to the nearest whole percent, so no decimals, which is 31%. And probability of S given M. So now our denominator is going to change. We are only looking at the males. We're given males, so only look at either the 338 or the 1,352. Only look at the males. And we want to know, of the males, how many survived. So of the males, how many survived? 338 survived of the males. So 338 out of, remember our denominator is the total males, so 1,690. And that, as a decimal, is 0.2. And as a percent, that is 20%. It already is perfect with no decimals, so it stays as 20%. Now, the probability of females. There's no given, so the denominator is total, which is 2,115. And females. So the total females is 425. And that, as a decimal, is 0.201. As a percent, that's about 20.1%, which is about 20%. And here, notice that we have a given, so the denominator is going to change. We are given females, so the denominator will be total females, and we're only looking at the females. So of the females, only the females, how many survived? So of the females, how many survived? That's 316. So 316 out of the 425 females survived. And writing that as a decimal, it's 0.744. Writing that as a percent is 74.4%, which, rounding to the nearest whole percent, is 74%. And for this last one, then, we are given survived. So the denominator is going to be total survived. And we are only looking then at those who survived. This is all we're going to look at, which means the denominator is the 654, the total survived. And we want to know, of the survived, how many are females? So of the survived, how many are females? 316 are females. And so writing that as a decimal, 316 divided by 654 is 0.483. And writing that as a percent is 48.3%, which, rounding to the nearest whole percent, is 48%. Historically, when populations are in danger, societies prioritize protecting women. Does the Titanic data support this priority? Explain why or why not. Well, given the males, so given just men, this one right here, only 20% survived. So if we think of just the men, only 20% of the men survived. Given females, though, so given just the females, only looking at the girls, 74% of the girls survived. So yes, the Titanic prioritized protecting women. 10,000 course grades were given to students at the University of New Harmony last semester. And using this table then, let's answer these probability questions. We want to find the probability of L. L is the grade is lower than a B. Notice there's no given, so the denominator is going to be the total. Total is 10,000. And then we want to know how many grades were lower than a B. Well, there were 3,656 grades that were below a B, that were lower than a B. And so writing that as a decimal, we have 0.366. And writing that as a percent, we have 36.6%. And now we want to find the probability of E. E is the grade comes from an engineering and physical science course, given that the grade is lower than a B. So given is now our denominator. We are only looking at the below B grades. So we're only looking at 3,656 grades, which means that is the denominator. And of these grades that are below a B, how many came from the engineering and physical science? That's 800. 800 came from the engineering and physical science. And writing that as a decimal, 800 divided by 3,656 is 0.219. Writing that as a percent, it is 21.9%. So of the grades that are below B, 21.9% came from the School of Engineering and Physical Sciences. Okay, this time we are given E, so we are given the engineering and physical science grades. So we're only looking at these numbers here, which means the denominator is going to be the total grades from an engineering and physical science. So our denominator is 1,600. And of these grades, which ones are L? L is lower than a B. So lower than a B, that's 800. So we're looking at this 800 again. And writing that as a decimal, 800 divided by 1,600 is 0.5. Writing that as a percent, it's 50%. So given that your course was in the engineering and physical science school, so given that your course was in the engineering and physical science school, 50% of those students scored lower than a B. All right, I want you to try this last example on your own. Go ahead and pause the video now. All right, here are all of the answers. If you got any of them wrong, come chat with me about it next time in class.